This video is to help you to understand the types of problems that I'm having you figure out here. The wording's a little bit different. Probably the first thing that you need to understand is that the direction in which we can do the conversions isn't just one direction. I agree. I have given you this type of conversion where you go from kilograms to grams to moles, from moles to molecules, and then to atoms. I think what we're getting stuck on is that we can only read from left to right. However, you have to be able to also read from right to left. Okay? So if you're reading from right to left, then this could be your option. In other words, this goes from largest to smallest. We could also do smallest to largest. Okay? Just realize that the sequence is actually the same, just in the reverse direction. Okay? To grams to kilograms. Okay? So don't get all hung up and go, whoa, wait a minute. You taught us this way. Well, you should be able to go backward as well. And also do realize that the kilogram here is just a representative of the possible metric conversions. I could also stick milligram in there, milligram, nanogram, picogram, whatever. They're all good. We like those types of conversions. So don't get hung up and be stuck with just this format of reading from left to right. You should be able to answer any question that if I give you a certain number of atoms, that you should be able to convert to kilograms as well. However, do realize no matter which way you're going, okay, if you're looking at it this way, going that way, or this way, going that way, whatever you start with and whatever direction you're going, these are the units that should be on top in your factor labeling. Okay? I'm going to erase this bottom one here, but do realize that we could have this sequence either way. Okay, I'm not going to work out any more math problems. I think you're well aware of knowing how to figure that out, so I don't need to work any of those out. I did give you the even answers online in the answer form, so you can check that. So I'll go over the odd problems here. So this might help some of you. Some of you can fast forward to other questions if you want. I'll keep it in sequence. So the first odd one is number 5, where it says, or it's asking, calculate the number of molecules in 568 milligrams of gold 3 nitrate. Hopefully that one's not an issue. Since I'm asking for milligrams, we won't use the kilogram, but we'll actually go in this sequence. We'll convert from milligrams to grams. But this is where we're starting. So write down what you know. 568 milligrams, and this is of gold 3 nitrate. You still have to know your 10 polyatomics. You still have to be able to write chemical formulas. You still have to know your 52 elements and symbols. Okay? You still have to know all that stuff that we learned earlier, so don't forget it. So gold 3 nitrate. Okay? So Au has a +3 charge, the nitrate has a -1. We need 3 of those. You have to do this. Okay? Don't just write AuNO3. We're beyond that. Okay? We are well beyond that point right now. We're not in the point where we just write 1 and go. All right? The question wants to know how many molecules. So we're starting here, and we're going to go to here. Okay? It's nice to know where you start, and it's nice to know where you're going. So we should go from milligrams to grams, grams to moles, moles to molecules. These are the units that should be on top in our factor labeling. So milligrams, we're going to put milligram down here, gram right here. Notice what's on top. Okay? Ask yourself always, which one's bigger? Gram is always bigger than milligram. How many milligrams are in a gram? Well, milli is 10 to the -3, so it's forced to move our decimal place. We must do it 3 times. There are 1,000 milligrams in each gram. No negatives. Remember that. No negatives. All right, so now we need to get our periodic table out because we're going to put our unit grams down here. Milligrams have been canceled out. So now we're ready to convert our grams to moles. So in 1 mole of gold 3 nitrate, that's one reason why we have to write that. We have to find out what the molar mass of that is. Gold has a molar mass of 196.97 grams. Get that from the periodic table. Don't memorize it. We have 3 nitrates. We have 9 oxygen. Okay? So now my grams have canceled that. If I calculate that out, let me actually calculate what that mass is before we go. 1 mole of gold 3 nitrate has a molar mass of 383 grams. It's exactly that, which is nice. Okay. All right, so all this mass right here is 383. You can either do that or you don't have to do that. That's your call. All right, so we're going to molecules. So we're going to move our unit mole down. Don't forget, whenever you're working with the variables or the units here, whenever we have mole within the problem, it's always going to be 1. Now, I could start you off with a mole amount, but within the problem, within the factor labeling, it will always be 1. So 1 mole of gold 3 nitrate has how many molecules in it? Correct. We will always have Avogadro's number of molecules in that. Okay. That's where we're looking for. That's the unit we have. Moles will cancel out. Let's type this in, see what we get. Calculator says 8.92, we'll say 93, times 10 to the 20. And that again is molecules. Okay. So hopefully everything's been typed in there correctly. That's question number 5. Let's take a look at number 7. It says calculate the number of moles of copper 1 nitrate if a sample has 1.52 times 10 to the 25 atoms of nitrogen in the sample. Again, we're starting right here. That's what it's asking for. So we're going to start with atoms. And it wants to know how many moles. So we're going this way. Okay. Hey, it's okay, guys. We're just going backward on this. So we're going to start with what's given. So it says we have 1.52 times 10 to the 25 atoms, and this is really important, atoms of nitrogen. Okay? You have to be aware or be able to read what it's telling you. Okay? So this is how many atoms we have of nitrogen, and it says it's within in a sample of copper 1 nitride. Okay? So here we go. Start with atoms, convert it to molecules. If it's not what you're looking for, move it down. So, how many atoms of nitrogen are in 1 molecule? Actually, let's write it. 1 molecule of copper nitride, copper 1 nitride. We don't know that until you actually write the formula. Copper with a +1, nitrogen, nitride, IDE, so it's an element, has a -3 charge. Means we need 3 of those. So in 1 molecule of copper 1 nitride, how many atoms are there of nitrogen? Correct, there's 1. There's 1 atom of nitrogen in every molecule of copper nitride. The unit atoms cancel off. Okay, so we're here right now. You just need to go one more step. What do we do with the unit if it's not what we're looking for? Move it diagonally. So we have molecules down here, and we're going to have moles on top. What do you give the value mole? Always give it a 1. So we have 6.02 times 10 to the 23 molecules. We have the unit that we're looking for. Our molecules have canceled out. So when we solve this, we're going to take this times 1 divided by Avogadro's number. And also, realize there's no molar masses here. Don't try to figure out any molar masses. Don't go another step to go backward. Just follow the sequence. All right, so after typing all this in, my calculator says I have 25.2 moles of copper 3 nitride. Let's take a look at the next one. Number 9. Number 9. Calculate the mass in grams for 3.33 times 10 to the 28 molecules of chromium 3 iodate. Okay, so it wants us to calculate the number of grams, so we're going to go here, and it gave us molecules. So we started there. Okay. So again, make sure that we follow the correct sequence, and this is a reverse direction, so it's okay. So number 9, we have 3.33 times 10 to the 28 molecules. And this is of chromium 3 iodate. We'll get to that here in a second. Okay. So when we convert from molecules to moles, again, move the molecules diagonal. And put mole on top, since that's the sequence of which we're going from molecules to mole. Again, always assign the value 1 to mole. And whenever we're going from mole to molecule, we're going to use Avogadro's number. Okay. You will never have a Avogadro's number of moles, ever. So don't get that creative on me. All right, I guess now's a good time to write the formula for chromium 3 iodate. Chromium, Cr, has a +3 charge. Iodate, IO3, with a -1 charge. It means we need 3 of those. Okay. So be sure you can still balance those. All right, so it wants us to go to grams. So we're going to take our 1 mole of chromium 3 iodate and move it down below. And now we need to find out what the molar mass of that is. So chromium has a molar mass of 52 grams. We have 1 of those. We have 3 iodines, and iodine's like 126. Yep. 126.91 grams. We have 9 oxygen. Okay. And since we're looking for grams, that's good. All right, and I'm going to go ahead and put that molar mass in there. So I get a molar mass of 576.73 grams. Okay. So we can do our equation, and again, it doesn't matter if you do it this way or if you do it that way. Just make sure that you can type it in correctly, and be very, very careful. Order of operation. Don't do this times this and then add 3 times those values. Make sure that if you're going to multiply this value by this value, this goes in parentheses. Okay. Order of operations, very, very important. So my calculator is giving me an answer of 3.1902174.42, which is 3.19 times 10 to the 7, and that is grams. Okay. Big number. Again, show scientific notation. Don't show what's on your calculator. We don't want to see something like that. Okay. We don't want to write that number down. Use scientific notation for 3 sig figs. Number 11. Calculate the mass in milligrams for 45.4 moles of titanium. Okay. So we're starting here, and it wants to know how many milligrams. So we're going to change that metric one to that. So this is what we're looking for. So we're moving in this direction. So we start with our 45.4 moles, and this is of titanium 3 sulfate. Again, titanium, Ti, and in this case it has a +3 charge. Sulfate, SO4, -2. So we need 3 of those and 2 of those. Okay. Since we're going from mole to grams, we're going to have grams on top, but again, that's our molar mass. So 1 mole of titanium sulfate. And let's find those values. Titanium has a molar mass of 47.9 grams per mole. Plus, oh, I'm sorry, we have 2 of those, so we need to multiply that by 2. We have 3 sulfurs, so 32.06. We have 12 oxygen. Okay. Since we are going to milligram, let's go ahead and show that step real quickly here. So these are grams, so I'm going to put gram here, going to milligram. Which of these 2 units is larger? Milligram is smaller, so we're going to give the value 1 to gram and there's 1,000 milligrams. All right, let's find the molar mass of the titanium. And again, it's up to you. Just remember that if you do multiply all this out, because we're going to multiply everything on top divided by 1, put this whole thing in parentheses. So again, it's your option if you wish to put that up there. So 383.98 grams. So 1.74 times 10 to the 7, and that is milligrams. Okay. Again, make sure your order of operation is correct. So if you were going to type this in, 45.4 times all of this, if you're doing it that way. Let's look at number 13. Number 13, calculate the number of molecules in a 1.44 times 10 to the 7 nanogram sample of zinc nitrate. Nanograms, gotta like that. So in this case, we're starting with nanograms. Okay, we're starting. And it wants to know how many molecules, so we're going to here. Okay. Start with what you know. So in this case here we have 1.44 times 10 to the 7 nanograms. And this is of zinc nitrate. So zinc and then nitrate. Remember, zinc has a +2 charge, nitrate's a -1. We need 2 of those. Okay. Be sure to convert the nanograms to grams. So nano goes here, grams go here. Which one's larger? Very good, gram. How many nanograms in a gram? Nano 9. Nano 9, good. Okay, so nanograms are gone. All right, and then we're going to convert from grams to moles. So again, it's moles of zinc. We'll put 1 mole of zinc nitrate on top. So we need to find the molar masses for that. So zinc is 65.39. Plus we have 2 nitrogen. Plus we have 6 oxygens. Okay. And we're looking for molecules. So again, use the unit, or move the unit over. So 1 mole is equal to 6.02 times 10 to the 23 molecules. And that's of zinc nitrate. Okay. Find out what that is. Okay. Again, if you need to calculate all that, might be a good idea since we have a lot going on down there. So the molar mass for zinc nitrate is 189.41 grams. Okay. So if you need to do that, go ahead and do that. Make sure you type everything on top. Make sure you do this correctly. Order of operation is paramount now. So do this on top, multiply that by that. Once you hit your divided button, open up the parentheses and then multiply this by this. Got a lot of scientific notation things going on there. So my calculator is saying that we're going to have 4.58 times 10 to the 19, and that's molecules. Molecules of zinc nitrate. Make sure your calculator can get that. Again, what we're doing, we're taking this times 1 times 1 times this. Hit your divided button. Open up your parentheses. 1 EE9 times 189.41, or 1 EE9 after the parentheses. Add all this up, okay? But make sure that once you hit times on this, that we're opening the parentheses again a second time. Let me type this in, or write it for you. So 1.44 EE or EXP, whatever it is that you're doing, times, or 7, times 1 times 1 times 6.02 EE. 23. Open up that division line, or division sign. Open up the parentheses. 1 EE 9 times, open the parentheses. If you're going to do this, 65.39 plus 2 times 14.01 plus 6 times 16, close the parentheses, twice. Order of operation, we need 2 parentheses here because we have that one there. Hit equal, it should give you that. Okay, that's if you did it right. Alright, the last one here, number 15, calculate the mass in kilograms for a sample of ammonium phosphate that has 8.88 times 10 to the 28 atoms of nitrogen in the sample. Awesome. So in this case, we're going to finish here, and we're starting here. Okay? And this is a nice one to finish on. Okay? Again, you have to write the balanced formula correctly. So let's start off with what we know. We have 8.88 times 10 to the 28, and that's atoms of nitrogen. Maybe we'll make it there. Okay? So we're going to go from atoms to molecules. So in one molecule of ammonium phosphate, make sure we can write ammonium phosphate correctly. We have, save some room here, ammonium plus 1, phosphate minus 3. We need 3 of those. Okay? How many atoms of nitrogen are in one molecule of ammonium phosphate? There's the nitrogen times 3. So we've got 3 atoms of nitrogen. The atoms are gone. Convert the molecules to moles. So we have 1 mole on top. Again, always have 1 for the mole. And then we're going to have 6.02 times 10 to the 23 molecules. Okay, so now the molecules are gone. Convert the moles. So 1 mole goes on the bottom. And again, it's of your ammonium phosphate. So 3 of those. So we can find the molar mass for that. And let's see here. So 3 nitrogens plus 12 hydrogen plus 1 phosphorus, which is 30.97, yes, 30.97, and 4 oxygen. Okay. And then we'll finish it out. I'll get the molar mass for that here in a second. So we're going from grams to kilograms, yes. So again, we're going to put gram down here, kilogram here. Which one's bigger? Kilogram. There's 1,000 grams in a kilogram. Now, one thing that I want you to notice is that I will never have a molar mass of 1 gram here. Never. Okay. The only time I have 1 gram is in a conversion like this, where we have nanograms or milligrams that we're finishing or we start with. Okay. So, and I see a lot of students over the years write 1 gram for the molar mass for 1 mole. Never going to happen. Never going to see it. All right, so let's find out what the molar mass for ammonium phosphate is. 149.096. Double check that. All right, so now we can calculate how many kilograms. So since you already have this on top, just multiply it by 8.88 times 10 to the 28. And then we're going to divide it by all of this. So open up your parentheses and don't forget you have 1,000 over here as well. 7,330. So 7.33 times 10 to the 3, and this is kilograms of ammonium phosphate. All right, on the quiz, you'll see problems very, very similar to this. I'll just change the names and the numbers. Don't get upset to which direction I go. Just be sure that you know that once you start somewhere, you're going to go one direction. You're not going to back up to go forward or go forward to go backward. Okay? So make sure you know where you're starting and know where you're going. Really important, guys.